Hi, I'm Lars. Welcome back to the C# workshop. This video is going to cover methods and method parameters. Methods are not hard to understand, but the parameters can be a little bit confusing. I will cover the more common used parameter types in this video. Then later on, I will have a deep dive after the series to cover topics like recursion, callbacks, and template pattern methods. Have you ever wondered what the worst bug in history was? I'll give you a hint. It was at NASA. Let's get to it.
Just like the last video, this video will get you the information that is needed to learn C#. In order to get the most out of these videos, I recommend watching them in their intended order. There will be deep dive videos after the course. Let's start out talking about scope and how parameters work. Scope of a variable means where is that variable is accessible. Non-object-oriented programming languages have global variables, and since C# is an object-oriented programming language, it does not have global variables. But there is a way that you can still have them, and I will get into that more in the next video. For now, take a leap of faith and see how scope works. First off, we need to understand that each method is like a small application, but only in the sense that methods get their own memory assigned to them. And when the method is finished processing the commands, the memory is released back to the operating system. You will hear developers say a variable or a method is no longer in scope, and that is what they're talking about. Using the console app that we've been using in this through the video series, we're going to start out with adding an integer. And it's going to just be a number, and I'm just going to set it equal to 3. And then down here, we're going to put a console in here of right line number, and we're going to put a string interpolation of root level with the number in it. And then we're going to execute it. And this will show you that at the root level, you're going to see number 3. And that's exactly what we expected. When I was talking about methods, a method's definition has to start with a return value. Okay, we'll get into the method accessors and all that other stuff in the next video. But let's just start with this. So right now we're not going to return anything. So that's a void. Okay, void means you're not returning anything back. And we're going to call this display number. Not going to take any parameters in. And inside of here, we are going to put another console right line. And I'm going to put a couple dents here. Display number. That's the first thing we're going to put in here. And then the next thing we're going to do is we're going to put a console up here. Instead of saying root level, it doesn't really matter. We're just going to display number. I'm going to say number equals number. And at the end of this, we're going to put another brace. So it sort of looks like a conditional. Okay. The difference is if I start trying to put breakpoints out here, I can put one there and they'll go one inside a display number, and then I can put one down here. Let me run this, and you will see that the int number getting set to 3 will get hit. That's the very first thing that happens. And then we jump over this method, and we end up running this. And it's going to be the same thing that you saw before. It's going to say root level 3, because we haven't done anything with the method. So I'm going to leave root level 3 here. And what we're going to do is going to do something called calling the method. Just like the console right line method, this is just a local method. And I don't need to put anything in front of it because it's here. And then let's execute this. So remember, I took the breakpoint at the top, so we're going to step down to here. And that's going to print out root level 3, just like you saw. And I'm going to hit F11. Now, you could also use this here to step into, but I don't use my mouse. I try not to take my hand off the keyboard. So F11 will step me into display number, and you see we hit that breakpoint. You didn't need the breakpoint there. It was just there to show you that we're not going to run that code. And then you can F10 or F11, and then it will print in display number, and it will print number again. Okay. Now notice it knows about number. It knows that it's accessible. So the scope of anything on the outside here will be available inside of a method. Okay. So this is your outer scope. Let's just call it outer scope right now, and this is your inner scope. If I come in and I put an int and I put a number in here and I set this number equal to 5, we have overridden this number value here. All right. So let me explain to you what this is doing before I actually run it.
Hey, if you think there's too much information to remember, then like and subscribe to the channel. Then you'll have a URL that you can go back and look at anytime.
So what happened is when we created the method, we did create a stack in a memory, a variable stack in the memory to put the data into. However, we don't have anything in here, so it's going to remain empty. And when we utilize to say I want to print number out, it's going to go up to its parent, which is int number in the base, and it's going to grab that number 3. Now what I did is I added an int number, I declared one inside of the method display number. What that did is that put number 5 inside of the variable stack in the memory, local to display number, basically overriding the original number in memory. So what is happening here is since we have number that's in our local memory bank, we don't need to go up to number 3 up here to find out where number is. Now if we run this, I'm just going to step through it. So we display the root number, then we go into display number, and then number 5 gets set. Okay, and we write line number, and we come back out. Now I'm just going to mouse over this number here, but you can see this number is still number 3. All right, this still is number 3. We haven't overwritten number 3. It just utilized the one that was inside. So when we look at the output here, we have the root level, which was 3. Then we went into display number, and then we pulled this number out of the method's memory bank. Okay, the memory that's allocated to the method. And that had a number 5 in it. All right. So this is a different scope. This is a local scope. This is a global scope. Now remember, there's no such thing as a global scope, but you'll understand after we get into classes what I'm talking about. Now you can see that the display method has a different level of scope that overrides the outside scope. Let me show you something that is not real common. It's not common practice hardly at all, but you can add more methods inside of a method, and that will even bring the scope even tighter. And let me show you how this is done. In order to do this, the first thing we need to do is we need to add another method in here. And I'm just going to call it internal method. This method is not accessible outside of display number. As you can see here, if I try to call it, you will get a method that does not exist in the current context. However, inside of display number, we can call it anytime we want. So something like this would be used if you had a calculation that you only wanted to be used by this method here. This is not a common practice in the computing industry, but I want you to know that it does exist just in case you come across it. I've seen it a few times, and usually it's because there's a calculation that's inside of here that is unique to the outer method, and there might be a couple different methods that are doing the same type of calculation, sorta, but these have very intricate parts to the method that it's in. So what I am trying to convey about scope is this is the scope for number 3. If this number here was not here and this was not here, this number 3 would be accessible through all of these methods. However, if this number comes in, it overrides the number up here, all right, the outer number. And then this will be accessible through both of these methods. Once you put in a number 7, it will override this number 5, which is already override number 3, and this will be the scope for this number 7. So let's run this and see how it works. Application will execute line 3, and then it will skip the methods, and it will start executing line 25. So let's step into display number. So this here will instantiate a new number in this method's memory location. And as you can see, number is equal to 5. And when we step into internal method, this number will be instantiated into internal method's memory location. As you can see, there's nothing been displayed yet. And then we will write in internal method and print out number, which is number 7. All right, so number 7 has overridden number 5, has overridden number 3. It's a way you can look at it. They're not really overriding, they're just in different locations. And we will step out of the internal method and show you that number 5 is now accessible. So we will print it out, and then we will step out of display method, and at this point, number 3 is accessible. And this is what you end up with at the end. Now let's talk about parameters. This is what's called a value parameter because int is a value type. Since it is a value parameter, it acts like one value type being assigned to another value type, and it gets copied into the memory location of the method. And I will show you this now. An input parameter for methods helps with encapsulating operations and protecting processes. And a lot of people, when you first look at them, they don't really see them like they are really important. But without a method to encapsulate an operation, this is what it would look like if we needed to use this logic 4 times. So let's just say we had a number and we needed to print this out 4 times. And that's okay, not that difficult, it's easy to understand. But what if these 4 lines were 10 lines apiece instead of just 1? Like say we had 40 lines here, and every time we had to change something, you'd have to do this all the time. Like say instead of saying root number here, say we wanted to say, base number, then you'd have to go through and change this multiple times in multiple places. And yeah, you could probably use something else, but I'm just giving an example. A good call would be to make this into a for loop. So like you say, for loop is equal to 1, 2, 4. And that would solve it. That looks pretty good. And it's the same thing. If we run it, you're still going to get base number equal to 3. It's just going to be there 4 times. Now what happens if this for loop has to be used in a couple different places? Okay. So this is pretty clean. Still maintainable. Nothing that's really bad. But maybe this guy here only ran twice, and maybe this one here is running 6 times. Maybe say we want to take and, let's say this is amount 1, because say this is going to be random. Other people are starting to use it in other locations. And this is where you start ending up with, like, this one here is going to be 2, and this one's the number 3. It's going to be equal 6. And this allows you to, put this wherever you want. Now, what if I was to take, number 2 here, and like we're going to put it into here, and now this is going to be number 4. You see how confusing this gets really quick? And say 4 is running for 4 times. I don't know. So this gets kind of confusing pretty quickly. So did you see how this whole scenario went from it was pretty easy to maintain, then it became hard to maintain, then it came back to being maintainable, and then it became very hard to maintain. This is no different than what happens in the IT industry. Specifications and codes change. Knowing when and how to adapt is what is important. For our scenario, we now need a method. Probably a few steps before now would have been a good time to put the method in. And eventually, you'll be comfortable enough with methods that you'll use them every day, and that day's not far away. So let's clean this thing up, and we'll leave this like this. Like that. Now, say we want to put this into a method. So we say void. It's going to call this display number. We've been kind of working with that for a little bit. So that's something that we could do. But you still have this amount. You'd have to change this amount every single time. So what somebody came up with was the idea that we could take amount and put it in a parameter as a parameter like that. And while we're at it, let's just take the int number with it also. You don't have to. I mean, it could stay on the outside. But this would allow you to print any number any amount of time. So if you come in and you say display number, and we're going to display number 3, and say you're going to display this one here 4 times. or 2 times, or 6 times, and say you want this to be the number 5. This is easy to do, right? So I'm going to put a right line in between these so you can see how this works. Like that. And now we'll run this. This is a lot more maintainable than the other code that we just saw. Plus, if you didn't want to do, if you wanted to add another one of these guys in here, say you wanted to add another, didn't know what it is. This is the number 4 one that you're bringing in. This one's going to be displayed, say 3 times, and it's the number 9. You could just drop it in. You don't have to worry about getting these confused. This amount is no different than what we did before. We were copying this all over the place. The difference is we are sending this number 3 into this method's memory, into a variable area that has the number in it. And this 4 gets put into the memory of this method's memory area for amount. Once this is run, this will be removed from memory. So we are freeing memory as we're going. If we were to drop this in as we did before with for loops, and we had all these other variables, all that stuff's going to stay in memory. This is another benefit of having methods. So this shows you how a value type parameter works. Now let's move on to a reference parameter. Sometimes a copy of an object is just not enough. And instead of copying the object and putting it into the method's memory, you actually need a pointer back to the original object. The only way to do this is to use a reference or a ref parameter. This is just like a reference variable. The parameter will be pointing back to the data residing in the calling location's memory. As you can see in the diagram, only memory used by the method is the existence of the pointer. The way that you add a reference parameter to a method is just like you would a regular parameter, except you would put ref in front of the data type. Now, just because ref is here and here does not mean that we can't add another variable over here, say value 3, that is not ref. When you're calling the said method with the reference type, you need to put ref in front of the variable that you're sending in. One thing that I'm going to make really clear here, because it does cause confusion, is once you're inside of the method, the int value 1 and int value 2 turn back into value types. So they act like value types in here. So inside, when you say value 1 is equal to value 2, all you're doing is taking and making a copy of value 2 and putting it in 1. The ref portion of this is from called the perimeter of the method to whatever variable you're sending in. So value 1 will be a pointer back to number 1. Value 2 will be a pointer back to number 2. Number 1 is going to hold this number. Number 2 is going to hold this number. All right. So it's pretty simple. So for this here, we're going to count in binary, and I'm going to run the application so you can actually see it run. If you remember about counting in binary, it's you just double. So you go 1 is doubled to 2, is doubled to 4, is doubled to 8, is doubled to 16, and so forth and so on. So let's step through this. And we have the output here. So number 1 is 1 currently, number 2 is 2. Value 1 and value 2, they're not even on the board yet. So if we step down in here, as soon as you hit that, they come on the board because now they're pointing back to number 1. Value 1's pointing to number 1 and value 2 is pointing to number 2. And yes, I made these different names because I want you to see that there is a difference between them. And as we step down in here, you're going to print out a 1, and then value 1 is going to get the 2. And then value 2 is going to get value 1 plus value 2. So 2 plus 2 is equal to 4. So value 2 got increased. Now when we leave here, you're going to see number 1 and number 2 are going to get these values. See? Now they got 2 and 4. Let's go through it one more time. So we're starting out with 2 and 4. You go in, and value 1 and value 2 get 2 and 4. We're going to write out value 1, which is 2, and then value 1 is going to get the value 2. The main reason I did this copy here like this is to show you that these are value types. So when we hit F10, value 1 changed to 4. And then value 2 is going to be 4 plus 4. It's going to become 8. And then when we leave, these two here will update, and they'll turn red. Boom, 4 and 8. All right. It's a pretty simple application. It's not super hard. All it does is count in binary. All right. And again, I know there's many ways to do this. So let's move on to another example that's dealing with ref parameters. So this is acting the same way. This one here, we are just adding, we're counting in Fibonacci. Okay. So Fibonacci is the original number 1 plus the number next to it, which is 2, and then that would give us the third number, which is 3. Then you would take 2 plus 3 would give you 5. All right, so let me just run this and I'll show you what it looks like. So they count 1, 2, so it's 1 plus 2 is 3, 2 plus 3 is 5, 5 plus 3 is 8, 5 plus 8 is 13, 8 plus 13 is 21. I think you get the idea. All right, and this is called the Fibonacci sequence. So again, value 1 is pointing back to number 1, value 2 is pointing back to number 2. This is only on the outside of the method, it's not within. Everything inside will still act as if they were an int value 1 and value 2. We're going to display value 1. We have to calculate the next number. I'm not going to get into all the math of this, but you have to calculate the next number because you have to take these two numbers that are existing and they have to drop into value 2. All right, value 1 just becomes value 2. Otherwise, when we print these out, it gets a little hairy. We're still going to go through the first 10, and I will step through these guys too. So the for loop gets executed, then you step in, and you can see the number 1 and number 2 are 1 and 2. And this time, let's add value 1 and value 2 to the watch. Okay, so inside again, these are acting, I'll put value, the next number here. These are acting as if they were value types inside. So value 1 gets assigned value 2, value 2 gets the next number. So there's 2, 3. As soon as we leave, this memory will get wiped. Okay, and then these numbers will get transferred back to the original numbers. So you can see they're 2, 3, 2, 3, 2, 3. Yes, I know the memory is not getting immediately wiped, but it is set for collection. So we'll step in again. Next value gets 5. Value 1 gets 3. The next number, value 2, gets to 5. And then when we leave, it goes to 3, 5. And this is how this works. So I don't know if you can see how this works. If you're not seeing it, please drop a comment in, and maybe I can go over this a little differently. But the main thing you're trying to realize here is that these are not being copied in anymore. They're being referenced back out. The last thing that needs to be discussed when it's coming to methods is how do you get a result back from a method? And there's two ways. In a procedure is what we've been working with. You can use the out keyword in front of your value type or a type, any type, and that will be returned out. Now you can't put values in on that, but it can have a value coming out. The second way is actually return a value back from a function. So let's dig into both of these and we'll finish up this video. So the first thing we're going to talk about is an out parameter. And these are not that common anymore, but they used to be pretty big back in the day when we actually had functions and procedures. And I still consider them functions and procedures. The difference between a function and a procedure is a procedure does not return a result set. Like it just doesn't come back from it. And you'll see that in a minute. But there are times where you need more than one thing to be returned. And that's where these out parameters come in really handy. So like we have this result up here, okay? And I want to put out int result here. And you can see we're already getting an error here. And that's reason being because if we put result is equal to number 1, we're just going to add these two numbers together, just some calculation. Then that will go away. And here we have calculate number, and we have an error because the out variable is not being set. So just like the ref, you need to put out and then result. So I'm going to put a little console here, console right line, and I'm just going to put result, because that's really the only thing that we can put there because I don't have any other variables. So let's put a breakpoint here. Actually, put it here and we'll let this thing roll. All right, so right now result is equal to 0 because that's the default for an integer. And we're going to send in 1 and 2. So here's 1, here's 2, and when they're done, it's going to be 3. When we come back out of this, result is equal to 3, and it will be written on the console, 3. Not rocket science, not something that's really difficult to do. One thing about an out parameter, typically I don't do is I don't ever set them to a value before going in. You can do that, they will come in, but it's not a good idea. It'll come in with a 9, but you can't use it once it's in here because it's been tagged as an out parameter. So just do yourself a favor and don't set them here. Another reason to use these is in case you need 2 results to come back. So you might have like a max and a min for something that you want to come back with. So if we put like, result 2 here, I don't know, plus 1, whatever, and you want to put another out here, result 2 on it, you can do that. You can put them all as outs if you want, if you have a bunch of numbers coming back. There's better ways to do this. I'm just giving you examples about methods. Get rid of these guys, and let's talk about a function. A function is something that you would return a type, like int. So let me get rid of this stuff here. And instead of saying result, you would just say return. And you could get rid of all this stuff in here like that. And you can put an int out here and say result is equal to calculate number. This works just fine. It's a beautiful thing, and I'm going to show you why it's a beautiful thing here. When we run it, you're going to get your 3 back. I'm going to drag us back up. It works just like you would think. Here's number 1, number 2, and then number 3 gets just pushed right back out, and it gets displayed. The one thing that is happening is this. This guy right here is being put into memory. Now, yes, it's still going to get put into memory, but it's not going to be its own part of memory. Okay, so this way here is going to just be displayed out, and you can do this. You can say right line and then whatever my calculated number is. All right, you could put another thing in here and say, let's put calculated number of 2 plus 3. And then if I put a breakpoint on this, and this runs, the first calculated number will come in. We'll have 1 and 2, and that'll return. And then if I hit F11 again, then it'll be 2 and 3. And then these two will be combined and written out. And the answer will be 8. So you got 3 plus 5 is 8.
Thanks for watching the video. Please like and subscribe to the channel. I really hope you enjoyed the video and understand the basics of methods and parameters. The more you use them, the better you will understand them. In the next video, I will start covering classes, beginning with namespaces and class structures. What was the worst bug in history? For me, it was a toss-up. Both were expensive and both were for NASA. Before I tell you this, I want you to imagine yourself working on each of the projects and figure out which one would be worse for you, and then drop it down in the comments, because I'd like to see where everybody's at on this. Because like I said, it's a toss-up for me. In 1962, the Mariner 1 spacecraft was heading to Venus. The cost was $18.5 million to build. That's 1962 money. In 2025 money, that's $193.3 million. The bug was in the guidance system of the software. Equations to use to process and translate tracking data into flight instructions were encoded on punch cards. You got to remember, it's 1962. One critical symbol was left out. It's an overbar or an overline. A lot of people confuse them with a hyphen. This caused the compiler to incorrectly compensate for some otherwise normal movement in the spacecraft. After 290 seconds of flight from Cape Canaveral, they had to send a command to self-destruct. A simple test could have prevented this accident, and I'm glad I was not on the team that made the punch cards. The second one, on December 11th, 1998, the Mars orbiter was sent to Mars. The cost was $327.6 million in 1998. 2025 money, $620 million. On September 23rd, 1999, it's about 9 months later, right? The spacecraft reached Mars and attempted to set up orbit around Mars. The orbiter encountered a critical failure in the orbit insertion attempt. The orbiter was lost due to a navigation error caused by a unit conversion mistake between metric and English system of measurement. Lockheed Martin had provided the crucial acceleration data in English units, while the navigation team at NASA's Jet Propulsion Lab, or JPL, used metric units. The mismatch led to an incorrect trajectory calculation, causing the orbiter to approach Mars at a lower altitude than planned. As a result, the spacecraft encountered excessive atmospheric friction and was destroyed. I'm glad I was on neither team on this project too. So let me know in the comments which one you think is worse and why. You're always welcome here at the C# Workshop, and as always, have a nice day.